Hello everyone. In this video, we will learn about stacking. Stacked generalization, which is also known as stacking, is an ensemble learning technique. It extends voting by using a trained combiner model. The combiner is another learner that determines how to best combine base models' outputs. Unlike simple voting, stacking learns from the base model's errors. The combiner model is trained to minimize biases. It helps in estimating and correcting the weaknesses of base models. Stack generalization formula. The combiner model is represented as y is equal to function of d1 d2 till dl given pi, where this di represents the outputs of the base models, f represents the combiner function, and pi represents the parameters of the combiner. Let us understand the working of stacking. There are some basic key components. The first thing is input data. This input data is denoted as X. The original data set is used for training, and this data is fed into the multiple base learners. And these are all the base learners. These are different ML models trained on the same data set, and each base learner is going to give a output or some prediction. And this output given by the base learner, it can be the probabilities, regression values, or classification labels. The third component is the combiner function. This is a higher level model that learns how to best combine the outputs from the base learners. And this is also trained using a separate data set to generalize. This function can be a linear model, neural network, or another ML algorithm. And the final component is the output y. This is the final prediction made by the combiner model. It is expected to be more accurate than any individual base models. The working of stacking can be summarized in 4 steps. The input data X is first processed by multiple base learners. Each base learner produces an output D1, D2 till DL. These outputs are then fed into the combiner function, which learns the optimal way to integrate them. And final step is the combiner produces the final prediction y. Advantages of stacking. It utilizes the strengths of multiple learning algorithms, reduces bias and variance. It works well for classification and regression problems. It outperforms simple ensemble techniques like bagging and boosting. This is all about the stacked generalization. Thank you.